Okay, madam, start.
Welcome to MRU E-Learning, powered by Malla Reddy University. Myself, Sriram Anusha, working as Assistant Professor in Department of Data Science, Malla Reddy University, School of Engineering. Here in this presentation, I will discuss about the dynamic memory allocation. Before going to discuss dynamic memory allocation, I want to explain the following concepts related to the dynamic memory allocation. The first concept is basic idea of memory allocation, and second one, types of memory allocation. Third one, introduction to dynamic memory allocation. Fourth one, need of dynamic memory allocation. And next, the functions related to the dynamic memory allocation. The last but not least, I will explain dynamic memory allocation by using functions with an example. Now, in this session, I want to explain the first topic is memory allocation. Memory allocation in any programming language determines how and when memory was allocated for the variables or data structure during program execution. Efficient memory management is playing an important role for the programmer to build optimized programs as well as error-free programs. In C programming language, the memory allocation was divided into two types. The first one is static memory allocation and second one is dynamic memory allocation. Before going to discuss types of memory allocation, it is important to know how the memory is organized in a program. The memory layout look like 4 blocks. The first one is code section, second one is global variables, third one is stack, and fourth one is heap here. Every program which is contains code section and data section. The data section which is related to the variables. There are two types of variables, that is local variables and second one is global variables. The local variables which are stored in the stack and global variables are stored in the block of global variable section. And the code section means the program which contains the set of instructions which are compiled and executed within the computer system. That code section is allocated in the code section block of the memory layout. And so here the code section means storing the code section means the program. The program is a set of collection of instructions going to be compiled and executed within the computer system. Whatever the statements going to be compiled or executed within the computer system, those are loaded in the code section. And what is the data segment? The program which is holding the data section, in that section, the variables are declared here. Whatever the variables are declared in the data section, that is stored in the data segment layer here. So the data segment which is holding the global as well as the static variables. And what is a stack memory and a heap memory? Stack memory means which is storing the local variables and the function called data. So the program is a collection of one or more functions with variables. Whenever the function is calling, that function is loaded into the memory along with the local variables of that function. After execution of the function, that variables allocated to that function as well as the function is released from the stack. So stack is working based on the last in first out structure. And what is a heap memory? The heap memory is used for the dynamic memory allocation. Memory is manually managed by the using pointers here. Pointer variables are playing an important role in the heap memory. So the first type of the memory allocation is static memory allocation. Static memory allocation is mainly for the variables declared at the declaration part of the program here. Whenever the programmer declares the variable at the declaration, the memory is allocated for those variables at the compile time. And at the declaration part, the compiler understands that how many number of variables and what are the types of the variables and how much size is allocated for those variables are gathered at the compile time. And memory is fixed that total declared variables, those fixed memory should not be changed during the program execution. And this total memory allocation is managed by the compiler. So let us take one example here in the C programming language. Int A is equal to 3, comma B is equal to 2 here. So where A comma B are called as variables. And these variables are, how many number of variables are 2, and the type of the variable is integer. And the size of the integer is 2 bytes here. So total memory is allocated for these variables is equal to 2 into 2 bytes. That is totally 4 bytes of memory is allocated for the local variables, for the static variables. These variables memory is allocated at the declaration part of the program here. So these variables are called as static variables, and whatever the memory is allocated for this variable should not be changed during the execution. So which means static memory allocation is called as a fixed memory allocation. And let us take one more example related to the array. I declared an array. The array name is ARR, and which is the size of the array is 5, and the type of the elements in the array is integer here. Array square bracket 5 means the array which is holding the 5 elements, all elements are integers here. And how much memory is allocated at the compile time means the number of elements 5 and the size of integer. Size of integer that is 5 into 2 bytes. Totally 10 bytes are allocated for the array variable. And in this 10 bytes should not be changed during the execution. So here for loop is used to give 10 bytes of memory. So 10 bytes of memory we have to give 5 elements. How you are giving? By using the for loop. For loop is used to repetitive execution of the statements, and you are giving the values to the array by using the for loop. The first one is I is a loop control variable. By using I is equal to 0 to the condition is I less than 5, because we are beginning with the 0, and to the 4 means totally 5 number of elements we have to give by using the for loop. And the first element array of 0, you are giving the value is 0 plus 1 is 1 value. And next that it is again it goes to here, I is incremented by 1 and I plus 1 is 2. Like that you give the first element value is 1, 2, 3, 4. Like that we have to give values to the array here. So totally the elements are displayed on the monitor by using the printf function, which is used to display the 5 elements from the array one by one by using the array square bracket I here. So whatever the memory is allocated to the array is, that is 5 into 2 bytes, totally 10 bytes is allocated for the array, which cannot be changed during the memory, during the execution of the program. So this is called as a fixed memory allocation that cannot be changed by any programmer by doing the various types of operations. And what are the advantages? What are the advantages of static memory allocation? The advantages are, the first one is simple usage. Every normal person can easily understand the static memory allocation concept while developing a program. And every user can allocate and deallocate the memory done at the compile time. And it is very execution. Static memory allocation. What are the advantages and disadvantages of static memory allocation? The advantages of static memory allocation. The first one is simple usage. Every programmer from the beginner can easily understand the concept of static memory allocation and develop the program easily. and allocating and deallocating the memory for the variable at the compile time is also done at the static memory allocation, and the execution time is very efficient, and it uses stack data structure to store the variables in stack memory in continuous allocation of the blocks in the main memory. And what is the disadvantage of static memory allocation? The memory wastage problem here. So for suppose here we are declaring the array with four size. The A is allocated with 4 blocks here. The first block name is A0 to A3 here, and the number of blocks are allocated. The size of the memory is 4 into 2 bytes. Totally 8 bytes are allocated here. For suppose memory wastage problem, how it is arised in this static memory allocation means while executing the program, the user has given only 2 values. For suppose 10 is given to the A of 0 and he has given 20 at the A of 1, and he is not giving the remaining values. So here the wasting of memory is done by the user while entering the values to instead of 4 he entered 2 values, so he is not using the 2 memory blocks for his program. So this is this problem is occurred in the static memory allocation. Exact memory requirements must be known. So whenever user develop a program, he must know the exact memory allocation for the variables. How many variables are required, and what are the types of variables, and the size of the variables must be known by the programmer. Then he can't know the all the details, so that he will get the errors like system crash type of errors. So memory cannot be resized once after initialization. Once you enter the values into the memory blocks of the array or any variable, the memory cannot be increased or decreased by operations done by the programmer. So whatever the operations are done by the programmer based on the allocated memory to that particular variable or array here. So here the problems are wasting of the memory, and next one is we can't increase and decrease the memory during the execution of the program, and the exact memory requirement must be known before going to be execution in the computer system. So this is the disadvantage of static memory allocation. And next, the main concept, that is dynamic memory allocation. So dynamic memory allocation refers to the process of manual memory management, which means allocating and deallocating the memory within the heap at any time, means at the time of execution, is called as dynamic memory allocation. Dynamic memory allocation in C programming language performed by the following library functions. That library functions are malloc, calloc, realloc, and free functions. These are the library functions which are operated on the dynamic memory allocation, and these are predefined in the library stdlib.h. This library header file is provided for the dynamic memory allocation. In this header file, these are the library functions are defined here. And these 4 functions only performed for the dynamic memory allocation, and by using these functions we can access the heap memory, and in the dynamic memory allocation, pointers play an important role. By using the pointer variable, we can access the memory we can allocate the memory, and deallocate the memory can be done here. And dynamic memory allocation has runtime memory allocation. So it is not a fixed memory allocation. The size of the memory can be increased or decreased during the execution of the program. So what are the needs of the dynamic memory allocation? Dynamic memory allocation allocates the memory at the runtime. So it is more flexible. Whenever we need extra data, we can extend our memory during the runtime or execution time. Whenever we whenever we don't require the memory, we release the memory during the execution. We can delete the memory and we can allocate the memory at the runtime. That is a facility provided by the dynamic memory allocation. So dynamic memory allocation providing the allocation, deallocation of the memory. That's why it is called as a flexible compared to the static memory allocation. And we are reallocating the memory, not only allocating the memory, and we also reallocate the memory by using the library functions provided by the dynamic memory allocation. And after using the memory, we can also release the memory by deleting memory performed by the function. Library function is called as a free function. So the dynamic memory allocation is very efficient compared to the static memory allocation. And dynamic memory allocation mainly used to implement data structures such as linked list, stack, queue, trees, graphs, like that. So this is advantage of dynamic memory allocation. And dynamic memory allocation is implemented with the following 4 functions, library functions, which are mainly used to manipulate with the dynamic memory allocation. The first function is called as a malloc function. Malloc means memory allocation function. M stands for memory allocation function. Calloc is a function which means continuous allocation of memory, and a reallocate means reallocation of the memory, and free means deleting the memory from the heap memory. So malloc, calloc and realloc are the functions for allocating the memory, and free means you are deleting the memory. So first one, I want to discuss the first library function in dynamic memory allocation is malloc function. Malloc stands for memory allocation. Malloc stands for memory allocation. Memory allocation is done by the malloc function. Malloc function reserves a block of memory of the specified number of bytes. So here the syntax is given. Malloc is taking one argument, that is a number is multiplied with the size of integer here. So this is an example. Here number is unsigned integer, which is multiplied with the size of the integer. The size of the integer is 2 bytes here. So malloc function is taking one argument, so that so it is reserved the block of memory of the specified number of bytes here, and it returns pointer, and the malloc function is taking one argument, and based on this argument it allocates the number of bytes required for your program, and also it returns the pointer of void which can be casted into pointers of any form. Malloc function does not initialize the memory allocated during execution. It carries garbage value. So whenever the malloc function, by using malloc function, you allocated 5 blocks of memory, but you are assigned only 2 values to those blocks, and 3 values are initialized automatically with the garbage values. So the malloc does not initialize the memory allocated during the execution. It is initialized with the garbage value when you are not initialized. Malloc function returns null pointer if it couldn't able to allocate requested amount of memory. What is the meaning of it? Malloc function allocates the memory from the free space of the heap here. Whenever there is no space in the heap, it returns null to the pointer, so variable. So it returns the null pointer. So whenever there is a free space in the heap, it can allocate those many bytes of memory in the heap. If there is no space in the memory, it returns just a null pointer. So we can, by watching the null pointer, you can understand that there is no space, that memory is totally occupied by the data. So here malloc function is example. The pointer return type is I am taking float star. So the pointer is a float type of variable. Malloc function is taking the one argument. Here I am taking 100 values multiplied with the size of float. So I am taking 100 float values. So we need 100 into float occupies 4 bytes. Totally 4 bytes of memory is required for this statement. So it's because the size of the float is 4 bytes, the number of elements is 100. 100 into 4 bytes equal to the 400 bytes. The 400 bytes are allocated for the pointer variable. The pointer variable taking all the elements from the 0 to 99. And the first address is 2000 I am representing with, and 2004 like that. And the pointer is a variable which is holding the starting base address, that is 2000. So in this malloc function, allocating the 100 memory blocks here, the first block location, the first block block number is stored in the pointer. So that pointer is pointing to the 100 elements in the memory. So the above statement allocating the 400 bytes of memory, it because the size of the float is 4 bytes, and the pointer, I am taking the pointer variable is a PTR. PTR holds the address of the first byte in the allocated memory. Next, calloc. Calloc stands for continuous allocation. The malloc function allocates memory and leaves the memory uninitialized. And whereas calloc function allocates memory and initializes all bits to 0. For example, here by using calloc function, you are allocating 25 blocks. All blocks are holding the float type of data here. So 25 elements, the pointer is holding the first block is at 2000 and second block is at 2004 like that, and the pointer which is holding the first block address, that is 2000, and pointing to the first block, and continuously it is pointing to the all 25 elements memory location. And whenever the user initialized values to those blocks like that 10 and 20 and 30 like that, if the user is not giving value to the 25th element, it automatically assigns 0 to the uninitialized block here. So that is the comparison between the malloc. If we are not giving value in the malloc function, a malloc function assigns the garbage value, but in the calloc function, it is automatically uninitialized values into the 0 here. Next, another function, dynamic memory allocation function, that is free function. So free function dynamically allocated memory by malloc, calloc, it does not get freed on their own. So whenever the memory is allocated by the malloc, calloc function, those memory is deleted by using the library function is called as a free function. The free function which releases the memory allocated by the malloc and calloc. And one more function which is called as realloc function. And if the dynamically allocated memory is insufficient or more than required, for suppose during the execution you need more memory you want for your problem, you can change the size of the previously allocated memory by using calloc and malloc. So you can extend the memory by using the realloc function. So the realloc is used for extending the previously allocated memory. And the example, I want to explain malloc and calloc and free function with an example. And here the first one, stdio.h, because in our program we are using standard input output functions such as printf and scanf, and printf and scanf are the functions which are defined in the standard input output header file, and we are also using the library functions related to the dynamic memory allocation such as malloc and calloc, realloc. Those are defined in the stdlib.h. Whenever you are using library function, you must specify the header file at the beginning of the program here. So we are taking the main function. Inside of the main function, first declaration of the variables, you are declaring the normal variables such as n1, n2, I, loop control variable, and also you are declaring the pointer variable star. Star specifies that it is a pointer variable, and at the first line of the main function you are declaring the normal variables as well as the pointer variables. And next one is these n1 and n2 are the how much size of memory you need. For suppose enter the size, how much blocks you need for the allocation. So n1 means n1, how much value for the n1 given by the scanf function. Scanf is used to give the n1 value by using the input device, and so you want to allocate the memory for the n1 size. So what are the types of the blocks is integer here. So integer, the syntax of the malloc function, malloc is taking the argument and n1 is multiplied with the size of int. And the return type is int star, and printf addresses of the previously allocated memory. So I is equal to 0, n1, I less than n1 plus I, and printf %u and pointer plus I. U means unsigned integer that displays the addresses of the allocated memory. So how many blocks you entered? For suppose you entered n1 size is 2, addresses of previously allocated memory is this is a 2 unsigned integer. These two values are called as a memory addresses. And next you want to extend your memory by using the realloc function. How to give memory for the extended memory to the pointer variable. So first one, printf, enter how much size you need, how much blocks you have to extend for previously allocated. Previously allocated 2 blocks, and I wanted to extend 4 blocks. So I want to extend into the 4 blocks by adding 2 more blocks. So by using the reallocation function is taking the pointer variable, and here new size is multiplied with the size of integer. And here for I is equal to 0 and I less than 2 and plus I, and it is taking how many blocks you want, that must be displayed on the monitor. So here see the first output, look at the output. First of all, enter the size of the n1 is 2. So the system automatically allocates the two blocks of memory, and the number of the block of memory is 268, 50, 55, 472, and next 268, 55, 476. And you want to extend 2 more blocks for the previously allocated blocks by giving the size is 4 here. N2 value I entered is 4. Now already I have 2 blocks and extending 2 more blocks by using the realloc function. So realloc function allocates the 2 more blocks for the previously allocated 2 blocks. Totally now I am having 4 blocks, that is from the 26855 and next block location number is adding by 4 bytes here, because the size of the integer in this 4 bytes. Size of the integer occupies 4 bytes. So that the first block address, by adding 4 to the next location, by adding 4 you are getting the next location, by adding the 4 getting the next location. So the size of the integer is 4 bytes. And here at the end of the allocation functions, that is malloc and reallocation, and we are using the free pointer. So free and using the pointer variable. So free function means whatever the memory allocated, that is 4 blocks are allocated, those free 4 blocks are released by the function is called as free function. Free function is used to remove whatever the blocks are allocated to your pointer variable. So in this program represents how the memory is allocated and how the memory is released by the dynamic memory allocation functions. Thank you.